Next, if you have a cubic polynomial, there can be two cases. So the cubic polynomial can be given in such a way that it can be factorized easily, or a cubic polynomial can be given in such a way that it cannot be factorized easily. So let us take the first case. So let us say that you have a cubic polynomial which is already factorized, or you have a cubic polynomial which you can very easily factorize. So let us take the following examples. So in the first example, all the three roots are distinct. The second example, 1 is a repeated root, 2 is a single root. And in the third example, you have 2 is a repeated root 3 times, x minus 2 whole cube. And y is equal to x minus 1, 1 is a root, and x square plus x plus 1 doesn't have any real roots. Now how do the graphs of these look like? What are the rough ways in which I can draw the graph? So what you need to do is, we use the concept of wavy curve method. We use the concept of wavy curve method. So what we do is, first you go for the first graph, and we know that the graph becomes 0 at 1, 2 and 3. 1, 2 and 3. So these are the points where the curve meets x-axis. Next, what is the leading coefficient? If you multiply these three, you can very clearly see that the leading coefficient is plus x cube. The leading coefficient is positive, plus 1. Hence the graph starts from here. So all the zeros have odd powers, that is 1 is a 0 and the corresponding power to x minus 1 is 1. X minus 2 is 1, x minus 3 is 1. So I am using the concept of wavy curve method. If the power of the corresponding factor is odd, if the power of the corresponding factor is odd, you can directly draw the wavy curve in this way. So you draw like this, you start from above because the leading coefficient is positive, and just to draw a wavy curve. So this will be the graph of x minus 1 into x minus 2 into x minus 3. As simple as this. This is the rough graph. And if you want these points, these are the points of maxima and minima. You need to differentiate this, get the values of x where you have maxima and minima, and find the values of y. So if you want these points in a question, so you have to go for maxima minima. Right? Mostly you will not be needing these points, you just need an approximate shape of the graph. So you got an approximate shape of the graph. Next, if you want the graph of x minus 1 whole square into x minus 2. So here 1 is a repeated root which is repeated 2 times. So how does the graph of this look like? Again we use our wavy curve method. So the zeros are just 1 and 2. The leading coefficient, as you can see, is positive. So you start from here. So you come back. So x minus 2 has an odd power. So the sign gets changed. That is, the graph goes from positive to negative. And at x minus 1, you have an even power. So at x is equal to 1, the sign of the graph does not change. That is, it is negative in the right neighborhood of 1. It touches and goes back. It touches and goes back. That's the concept of wavy curve, right? So if you have doubts in this, just go and refer the topic of wavy curve method. So whenever you have an odd power, the sign of the graph changes. Whenever you have an even power, the sign of graph does not change. That is, if it comes from negative, it goes back to negative. If it comes from positive, it goes back to positive. So this is how the graph of x minus 1 whole square into x minus 2 look like. And if you want the graph of x minus 2 whole cube, so how does the graph of this look like? So you have a single 0, just x is equal to 2. The leading coefficient is positive. The leading coefficient is positive. So you start the graph from here, from the top. And 2 is a repeated root which is getting repeated 3 times. X minus 2 whole cube. So you have an odd power. Hence the sign of the graph changes. So effectively, if you see, the graph goes from top to bottom. The graph goes from top to bottom, and it doesn't follow a straight line, obviously. So whenever you have a cubic root, as we see, if you have y is equal to just x minus 2, you have a straight line graph. If you have x minus 2 whole cube, whenever the power increases, the graph becomes flat at the point where it cuts the x-axis. So the graph will be something like this. It comes like this, it becomes flat near x is equal to 2 and goes like this. And even if you analyze with respect to maxima and minima, you'll see that you won't get any maxima or minima when all the roots are repeating. So you won't get any maxima or minima, you get a graph like this whenever you have a root which is repeated 3 times. Next, if you go for the fourth graph, so you have x is equal to 1 as a root, and x square plus x plus 1 does not have any real roots. So effectively, if you draw the wavy curve, you have only one root here. Only one root here. And that means the graph starts from here because the leading coefficient is positive, and it cuts here and goes like this. This time, do you have a maxima or minima? Here I can say that there is no maxima or minima, because if you differentiate this, you get 3 into x minus 2 whole square. X is equal to 2 is the critical point, but the differentiation on the right side of 2 and the left side of 2 are both positive. The differentiation does not change sign. Hence 2 is an inflection point. But here x equal to 1 is not an inflection point. So if you see the graph of this, whenever you have one single root and a quadratic, so we know that the graph is intersecting x-axis at only one point. But how does the remaining part look like? For that, if you want to be more specific, you can go for maxima and minima analysis also. So if you expand this, you get x cube minus x square plus x square gets cancelled, and plus x minus x gets cancelled, get x cube minus 1. X cube minus 1. So y is equal to x cube minus 1. dy by dx is 3x square again. So dy by dx is equal to 3x square equated to 0. So you get x is equal to 0. And as you can see, x is equal to 0 is an inflection point, because dy by dx is positive in the positive neighborhood of 0 as well as the negative neighborhood of 0. So if you draw the graph more carefully, the graph looks like this, that's okay. But if you want to be more specific, at x is equal to 1, y is equal to minus 1. So 0 minus 1 is an inflection point. So the graph looks like this. It becomes more flat at x is equal to 0, and then it goes up. So this is how the graph of x minus 1 into x square plus x plus 1 look like. So we have analyzed the graphs of cubic functions with respect to their zeros. So if the graphs can be factorized easily, you can draw the graphs of these cubic functions using wavy curve method. Now let us see how to draw the graphs if the graphs are not being very easily factorizable.